Okay, so we're on number 16 right now. And 16 says, solve the general direct variation equation y equals k times x for k. All right, so this is one of those literal equations, right? So they're saying basically we want k all by itself. So what are they doing to k? They're multiplying it by x. So let's divide both sides by x. And so, yes, you see that our k is equal to y over x. And that's kind of like the slope. And 16b says, what does this tell you about the ratio, fraction, involving x and y? It tells you, that the ratio y to x is constant. Okay, so we're going to use this idea in a couple of problems. It says some advantages of using a direct variation equation rather than a proportion. Proportions answer one at a time, but you can use a direct variation equation to answer multiple questions very quickly. 2, with the table feature in your graphing calculator spreadsheet, you can speed up the process even more when you have a direct variation equation. And 3, with proportions, you never actually see the conversion factor or the constant of variation. Like think about the gasoline problem. The variation equation shows us easily that gas was $2.22 a gallon. Okay, so he's saying the best gift that he got for his birthday was his own little mini-me. Not a living one, but a bobblehead made to look just like him. When scale models of real objects are made, the scale is often given as a ratio. In this case, the ratio of his mini-me size to the real thing is 1 to 13. Okay, so it says my mini-me is 5.82 inches tall. What a handsome little devil. So how tall am I in feet and inches? It says either set up and solve a proportion or use an equation of variation. Okay, this one actually, even after we read those advantages of using direct variation, this one lends itself to a proportion. So that 1/13th ratio that they gave us, we could say that this is the mini-me, and then this would be the actual. I guess I could have put bobblehead. And he's saying the mini-me is 5.82 inches tall, so that would go up here, wouldn't it? And we're looking for x. So when we cross multiply, get x equals 75.66 inches. But he said he wanted that in feet and inches. So let's use a little bit of dimensional analysis. Okay, so let's go ahead and divide that by 12, and we get 6.305. But that's feet. So we know it's 6 feet, but how many inches? Well, I've got 305 feet, and I need to go to inches. 1 foot is 12 inches. So 0.305 times 12 gives us 3.66, which is roughly 4 inches. I guess I should put that. There we go. Okay, then the actual mini-me from the Austin Powers movie is 32 inches tall, so we're going to use that same scale. Oops, 1/13. So again, this was his actual height. If he had a bobblehead made at the same scale as his, how tall would he be? Or how tall would it be? So let's cross multiply. I have 32 equals 13x. So let's divide both sides by 13. So 32 divided by 13 is roughly 2.5 inches tall. So there you have it.